Good morning, everyone. Welcome to my YouTube channel. My name is Vastikta. I'm a lecturer of electrical engineering. And today, we will be talking about an important topic of electrical engineering, that is rectifiers. So, here is the outline of today's talk. We will start with a quick introduction of rectifiers, move to their types, understand their working principle, and finally discuss where and why rectifiers are used. By the end, you will clearly see how such a small circuit forms the backbone of almost every power supply unit. After this session, you should be able to understand and describe what a rectifier is and explain its working principle, and secondly, understand the role of the PN junction diode in allowing current to pass in only one direction, and we will also discuss practical applications of rectifiers in various electrical and electronic systems. So, what is a rectifier? A rectifier is basically an electrical device that converts alternating current AC into direct current DC. In simple words, it rectifies the AC waveform so that current flows only one direction. Rectifiers are essential in power supplies, battery chargers, radio, and communication circuits. Basically, wherever DC is required from an AC source. So before understanding rectifiers, let's recall the difference between AC and DC. In AC, the current changes direction periodically, positive half cycle and negative half cycle. In DC, the current flows steadily in one direction. Rectifiers help us convert that AC nature into a unidirectional flow suitable for DC loads like batteries or electronic devices. The working of a rectifier mainly depends on a PN junction diode as it is made up of PN junction diode. So when the diode is forward biased, as we can see, it conducts easily, and when it is reverse biased, it blocks the current flow. This property allows the diode to pass only one half of the AC signal and block the other. That's how rectification begins. So we will talk about types of rectifiers now. Rectifiers are generally of two main types, half-wave rectifier and full-wave rectifier. In a half-wave rectifier, only one half cycle, usually the positive one of AC is used. In a full-wave rectifier, both halves of the AC waveform are converted into DC, either using a center tap transformer or a bridge configuration. Here we can see it is a bridge configuration. So now we will see working of half-wave rectifier. During the positive half cycle, the diode D becomes forward biased and conducts current through the load resistor, producing a positive output. During the negative half cycle, the diode is reverse biased and blocks the current, so no output appears. Thus, we get a pulsating DC output that exists only during the positive half cycle. Now we will talk about full wave rectifier. So it converts both half of the AC input into DC output. This is more efficient. There are two main configurations, the center tap rectifier using two diodes and the bridge rectifier using four diodes. Both produce continuous pulsating DC across the load. So in the first half cycle, one diode conducts while the other is reverse biased, sending current through the load in one direction. In the second half cycle, as you can see, the conducting rows of diode interchange, but the load current direction remains the same. As a result, the entire AC waveform is utilized, giving average DC output and better efficiency than the half-wave design. So this is a pulsating DC output. We can smooth it with the use of filter. So now let's summarize this session. So a rectifier converts AC into DC, and we also have studied that there are two types, half wave and full wave, and half wave uses only one half of the input, simple but less efficient, and full wave uses both halves, better performance and smoother output. So we can use filters help convert the pulsating DC into pure DC, and we will talk about filter in next session. So the rectifiers are indispensable in power supply, chargers, and all electronic system. So thank you for listening patiently. I hope this short session helped you understand how rectifier works and why they are so important in electrical and electronic applications. If you have any question, I will be happy to answer them now. You can ask in comment section. Thank you.